welcome back. Here we are going to solve some examples as a revision for what we did in the last few videos. First one said convert from degrees. So we got here degrees, and we need to convert them into radians. You remember when you need to convert from degrees, you have to multiply by the ratio by over 180. This to convert to radians. Multiply by over 180. So this angle here in degrees, to convert it, we just say 210 is equal, here degrees is equal to 210 times by over 180. Then we will make simplifying to get the answer. Here you can cancel 0 with 0 and divide on a 3 here, it will be 6. Divide on a 3 here will be 7. So it will be 7 by over 6. That's in radian. Which is written in abbreviation RAD. Okay? Same thing for the other angle. Negative 315 degrees. To convert it into radians, you say negative 315 times by over 180. And simplify this to get the answer. You can divide on 5, or here if you look to 315, you find it's the multiple of 45 actually. But anyway, you can just start with 5s. Dividing on 5 here, you will get 18 on 5, that's mean 3, and remain a 3 and 0, that's mean 30. On 5 it will be 6. Here dividing on 5s, that's mean 6 and remain 1, and in the front is 5, that's 15. On 5, that's mean 3. Again, we can divide here on 9. This here is 9. Common is 9. So here on 9, it will give you 4. Here on 9 will give you 7. So it will be 7 by over 4 radian. And negative, don't forget the sign, which is the same sign here. Okay? And so for the third angle, 36 degrees is equal 36 times pi over 180. You see, this can be divided on 9 and this on 9. On 9 here it will give you 4. Divide on 9 here, it will be 2 and 0 is here. Also you can divide on 4, both of those. On 4 it will be 1, on 4 here it will be 5. So the result is 1 times 5 pi, that's mean pi over 5 radian. And that's it. So every time you want to convert into radian, you have to multiply by over 180. Okay? Now let us do the inverse. Convert from radians, these angles given in radians, and we need to convert them into degrees. So we do the inverse also. To convert into degrees, convert to degrees, just multiply by 180 over pi. That means which is the inverse of this ratio. So the two operations are inverse of each other. Let us do for the first angle 4 pi here. 4 pi. We need to convert it into radians, into degrees I mean. So 4 pi times 180 over pi, which is this ratio here. And we make cancellation, pi with pi, and just multiply 4 by 180. That means 720. And don't forget to write here the symbol of degrees, which is the small circle here. Okay? Same thing for the other angle. 5 pi divided by 12. Convert it into degrees. That means just multiply it by 180 over pi. And we make cancellation here. Cancels pi with pi. Cancel the pi with pi. And here on 6 it will be 2. Here on 6 will be 3 and 0. Also divide by 2 here, it will be 1. Divide by 2 here will be 1, 5. Then we just multiply 5 by 15. So the result will be 75 degrees. Okay? For the last angle here, they just wrote 5 without give any symbol. When it's written like just number, it's known it is radian. If we put sign here, that's mean degree. If we do not put any symbol or logo, so we consider it radian. even if they do not mention that. Here they mentioned it's radian, but if they just wrote it like this without even mention it is radian, we will know it is radian. Multiply it by 180 over pi. Here, because there is no pi to cancel with pi, so we just make substitution about pi here, which is equal about 3.14. So 180 over 3.15, this times 5. It's actually 3.14 and so on. So I just wrote it 0.115 just to make it easier. But you have to write it accurate. And make after then the cancellation to get the accurate value in degrees. Okay? So those for these two questions. Now let us go to the third question. The third question asks me to draw in standard position each angle of those. The standard position, you remember, we need to draw the x-axis and the y-axis, and when you draw the angle, should put the vertex of the angle on the origin point, and put the initial side on the positive side of x-axis. So this is the initial for the angle. After then you start to move the terminal side in the direction positive, anti-clockwise, or in the direction of clockwise if it is negative. So here it's positive angle, so we will move from the initial in this direction, anti-clockwise. See 315, you know, complete rotation, complete revolution, here it's 360 degrees for complete revolution or complete rotation. So this is not 360, it is less than by 45. So we will start from here and move all this distance until get the half of the fourth quadrant, and consider it the sign or the final or terminal side of the angle will be here, and put the sign here to make mark like the angle is end at this line, which is the terminal side. So this is the angle 350 in standard position. Okay? Now let us go to the angle negative 150. We need to draw it in standard position. So again we will do the same thing. We just draw the y-axis and x-axis. And starting from the initial side will be here, and the vertex of the angle will be on the origin point. And here, because this is negative, we will move in clockwise in this direction. See, you will move 150 to know where is it exactly. You know the complete revolution is 360. Also the same thing if you move in the negative direction, it will be negative 360. Half revolution, that's mean 180. This 180 negative. This 180. But we will draw negative 150, which is mean less than 180. So it will be like here. This negative 90 and keep going, negative 60 more. So it will be negative 90 and 60, that's mean 150. So at this point we stop and we draw the terminal side of the angle here. And we write it's negative 150. You see? Now about the third angle, you see the third angle written in radian, negative angle in radian. Also the radians, will you know exactly where it will be? Consider here the full revolution or complete revolution is 2 pi. This negative 2 pi. Because it is complete revolution. Now we need half revolution, that means it's just 1 negative pi, like here. Here negative pi. When you look here, it is less than 1 pi. It's 3/4 of pi. 3/4 of pi. This quadrant give me pi over 2. And we will move another pi over 4. That means this point here, it will be here half pi and here 1/4 pi. So the final or the terminal side will be this side, and this is the end of the angle we need, which is negative 3 pi over 4. Anyway, complete revolution is 2 pi. Half revolution is 1 pi. Quadrant, only one quadrant is pi over 2. And half a quadrant is pi over 4. So it's very useful to remember these things. That's why here negative 3 pi over 4. Here is 1 quadrant, that's mean pi over 2, and half a quadrant, that's mean pi over 4. So those two total together, it will be pi over 2 plus pi over 4. That's mean 2 pi over 4 plus 1 pi over 4, which will be 3 pi over 4. And we do it in the direction of clockwise, that's why it's negative 3 pi over 4. Okay, so that's the third question done. Let us go to the last one. For this question, they ask me to find the trigonometric ratios for each angle mentioned here. Those angles written in radians. This in radians. There is no circle here, that's mean no degrees, but it is radian. First angle 4 pi over 3. The two axes, and 4 pi over 3, that's mean 1 pi, which is 3 pi over 3 plus 1/3 of pi. That's mean 1 pi plus pi over 3. 1 pi, that's mean the first quadrant and second quadrant. 2 quadrant, that's mean 1 pi. And there is pi over 3 also. So we keep going, pi over 3, that's mean till this point. So this the terminal side of the angle. So this is the angle. This is the angle 4 pi over 3. To know its ratios, the trigonometric ratios for this angle, which is 4 pi over 3, we will take any point here on this terminal side and draw this line. So here is right angle. Then this triangle here is right angle triangle. When this is pi over 3, that's mean here is pi over 6, here pi over 6, because these together, when we add them, should be equal pi over 2, like this, pi over 2. So pi over 2, the right angle, and the rest two angles should be equal also the same value, which is pi over 3 plus pi over 2 is equal to pi over 2. So as this pi over 3, then this will be pi over 6. As we know, pi over 6, the opposite for it, this one, will be half of the hypotenuse. So if we consider this is 1, so this will be 2. And by Pythagorean theorem, we can find this as square root of 3. So we can write all the ratios for this angle. The ratios for this angle, it's same the ratios for all this angle. Okay? So we can say here sine 4 pi over 3 is equal sine of pi over 3. But here you have to know this angle here in what quadrant? It is in the third quadrant. The third quadrant, according to the rules, said A, S, T, C. All students take calculus. In this quadrant, only tan is the positive. T is tan. So sine will be negative. Sine will be negative, cosine will be negative. So this negative and this will be negative. You see, it's in the negative side. This number in the negative side of x-axis. And this also in the negative side of y-axis. So we can write here, this is negative and this negative, according to the quadrant where the angle lies. So here we said the same sine of this angle, it's the same sine for pi over 3, but the angle, the ratio will be negative because it is in the third quadrant, which means negative square root over 3 divided by 2. Opposite over hypotenuse. This is the angle here, this is the opposite, this is the hypotenuse. And cosine, same thing. Cosine 4 pi over 3 is equal, here is cosine pi over 3. And also, because the third quadrant, it will be negative. So cosine for this angle, cosine is adjacent. Here's the adjacent of the angle. This angle is the adjacent over the hypotenuse. So it is minus or negative 1 over 2. Negative 1 over 2. Go for the third, which is tan. We said tan in the third quadrant is positive. So tan 4 pi over 3, it's the same tan pi over 3. And it's the same sign also. So don't need to put here negative. It is positive. So tan pi over 3, tan is opposite over adjacent. Negative square root over 3 over negative 1. Negative square root over 3 over negative 1. That means square root over 3. Because negative with negative change into positive, and this over 1, it will be this value. Now the inverse of these values give you the inverse here for sine is cosec. Cosec. In abbreviation CSC. For pi over 3, it's the inverse here. negative 2 over square root over 3. Cosine, the inverse for cosine is sec. 4 pi over 3 is the inverse of this, which means negative 2. And tan, the inverse is cotan 4 pi over 3 is inverse of this, that means 1 over square root of 3. So this is done. We will do the same with the angle negative 5 pi. Be careful here. Negative 5 pi. If we will try to draw it in standard position, we will find the terminal side lie on one of the axes. Here, this x-axis, here is y-axis, and when you draw a negative, we will go in the clockwise direction. Here is the vertex of the angle, and this the initial side, and we will start to move in this direction. Here is one pi, and keep going, so complete revolution, that's 2 pi. Keep going, that means 3 pi in negative. Keep going, that's 4 pi in negative. Keep going, that's 5 pi in negative. So this the angle. This is the angle. And you see the terminal side, this lie on the negative direction of the x-axis, here. This point here, what the coordinates for any point here? We know for the x, we said the value, if you consider just one here, that's fine. Consider any unit. So just x, in negative, of course. And y is 0. You see? And what about tan? There is no tan. Tan theta is y over x. Y is 0 over x, so it will be 0. So tan gone. It will be 0. So it's easy to write the ratios here. If you consider for angle, this angle, it's like the angle 0, but in direction negative. We say sine negative 5 pi is equal you see here, there is point here we need to talk about. When there's any angle like here, this the initial, and this is angle here. this the opposite of the angle. The opposite, what happened to the opposite when the value of the angle is changed? Increased or decreased? When it decreased, I mean it's like this became this. Let me enlarge the graph here, or the figure. Here's the angle. So the opposite is this length. But when the angle comes smaller, see, the opposite comes smaller. When it is smaller also, the opposite comes smaller. When it's coincide the two lines together, I mean the terminal and the initial, that means the opposite is zero. The opposite is zero. So here we can say the opposite here is zero. 0 over the hypotenuse, that means 0. So the sign will be 0. Because as we considered here, it's the same as sine the angle is 0. As it is, the terminal side is in the x-axis, we treat it same as we treat the angle here is 0. So sine for 0 is 0. Cosine for this angle also refer to this figure. When the angle came very small, we consider here the opposite became like 0. What about the adjacent? Adjacent and the hypotenuse became equals because they are coincide in each other. So that's why we consider the cosine is 1. Because when you say the cosine is adjacent over hypotenuse, when they are equal, that means they will become 1, I mean. So the cosine will become 1. Okay? Also for tan, we said tan this angle will be opposite over adjacent, but the opposite we said it is 0, so 0 over any value it will be 0. So for this angle, sine is 0, cosine is 1, tan is 0. But about the cosine here, we will be careful also, because it is in the quadrant which is not the first one. The cosine will be not positive. The cosine will be negative. So here you have to write it is -1. So this very important point. Always you have to be careful about the quadrant where the angle is when you write the ratios. So that's the difference between -5 pi and 0 angle. The 0 angle is in the first quadrant. The -5 pi, it's in the third quadrant. That's the difference. So there is difference in sign. For cosine, here, cosine 0, we know it is 1. But cosine negative 5 pi, it's negative 1. Because the quadrant here is the third quadrant. Here is in the first quadrant. That's why they are different in the sign. And about the other ratios, as sine is 0, there is no inverse for 0. Right? So we can list them here again. We said sine negative 5 pi is equal sine 0, which is 0. Cosine negative 5 pi is negative cosine 0, which means negative 1. And tan negative 5 pi is equal, here we said tan 0, which is 0. Also refer to the signs. All students take calculus. All students take calculus. So the third quadrant, tan is positive. In the second quadrant, tan is negative. But anyway, because it is just 0, so it doesn't matter we writing here any sign. Just we write 0. Then about cosec, the inverse of sine. Cosec, unknown. Because there is no inverse for 0 for this angle. Okay? And sec also, sec for this angle is the inverse here, which is negative 1 also. And cotan negative 5 by unknown, also there is no inverse, because so we can write unknown. Okay? Finally, the last angle. The last angle here is 11 pi over 4. 11 pi over 4. Which quadrant lie in this 11 pi over 4? You see, 11, when you divide 11 by 4, that means 2 and 3 over 4. That means this angle, as it is 2 pi plus 3 over 4 pi. Then when we write or draw the angle He did not ask me to draw it, but when we draw it, give me more understanding for the ratios I need to find them. I need to find them. Okay? So here you see 11 pi over 4, it's 2 pi, that's mean complete revolution, plus 3 over 4 pi. 3 over 4 pi, that's mean half of the second quadrant. We discussed this when we start to talk about this angle wrongly by consider it 3 over 4 pi, if you remember. So anyway, here's the terminal side of the angle, and here is the end of the angle. This is the initial side, and this is the vertex. So this is pi over 4, and this here pi over 2. So total will be 3 over 4 pi, because 3 over 4 pi, if you want to split it, it will be 2 over 4 pi plus 1 over 4 pi. This means pi over 2, and this means pi over 4, which is these two together. As this is pi over 4, then this one is also pi over 4. So this, the triangle here, with right angle here, this pi over 4, this pi over 4 also. Then if you consider this is 1, so this is 1, so this square root of 2, according to Pythagorean theorem. But here this one is negative, you see? It's because it's in this direction, which will give you the values. You will write them by considering the negative and positive. Here the second quadrant, the angle lies in the second quadrant. In second quadrant we said sine is positive. Sine 11 pi over 4. It's same like sine pi over 4. In second quadrant, sine is positive, according to here A, S, T, C. S, that means sine. Second quadrant is positive, and also sine is positive for the first quadrant. As we talk here about the second quadrant, so this one, which is positive. Sine is the opposite over hypotenuse. Opposite is 1, hypotenuse is square root of 2. That's the sign for this angle. Cosine cosine 11 pi over 4, it's cosine pi over 4. But consider here the quadrant, second quadrant, the angle lying in second quadrant, so the cosine will be negative. So negative here is equal adjacent over hypotenuse. Adjacent is negative, you see? Negative 1 over square root of 2. And tan 10, 11 by over 4, it is 10 by over 4, and also it is negative. Here when you divide those, they are 1 over negative 1, that's mean negative. Because in second quadrant 10 is negative also, and this will give me negative 1 over 1, that's mean 1. Here, opposite over adjacent. And now you can write the inverses. Here cosec 11 by over 4 is the inverse here. Square root of 2 over 1, that means square root of 2. Here, cosine, the inverse is sec. (11 by over 4). Inverse of this value, that's mean negative square root over 1. That's mean negative square root. And here cotan 11 by over 4 is equal, inverse of this is also the same value. Okay, so this one is done. These examples just to make revision for the information we got in the previous few videos. Thank you for watching, and see you again in the next one. Thank you, bye bye.